And so as I've started this recording, one of the things that I do want to share with you is that today's session is being brought to you by our Math Specialist Council. And as I said earlier, that Dave Martin is the president of the Math Specialist Council in Alberta, of Alberta Teachers Association. If you've not joined a specialist council, we definitely do encourage you to do so. It doesn't cost anything. And especially as math specialists, they do a lot of great work by putting on conferences and different workshops and opportunities to connect with people who are passionate about mathematics as well. So if you would like to join a specialist council, we highly recommend that. I'm just going to show quickly about how you would do that in case you didn't know. But if you were to log on to the Alberta Teachers Association webpage, there's a button up here that would say log in. I've logged in already just to save us some time. Once you've logged into the Alberta Teachers Association webpage, this allows you behind the firewall and allows you to see the members only information, but you'll be able to come down to your ATA tools and you will see Specialist Council membership as one of the tools that you have access to. If you click on Specialist Council membership, it's going to come to here and it'll say just click here to get a membership in the council. And by clicking on that, you can choose any one of the 21 specialist councils that you would like to participate within. Again, I do highly recommend the Math Council. They're doing amazing work. It's the first council that I joined as an Alberta teacher as well. And as I said before, every teacher in Alberta is allowed to choose one specialist council at no cost. So I'd encourage you after the session today, take a look and see what that looks like. But ultimately, we've got about 60 people here today that are excited to hear about high school math and what that looks like and some of the essential outcomes that we're looking at and how do we engage our students in this new world that we're in. So what I would like to do at this point is I'd like to turn it over to Dave Martin and have him entertain and have him just amaze you with his wit and his brilliance for the next 45 minutes to an hour. Go ahead, Dave.
Awesome. Awesome. How are you guys doing? You guys excited? Hey, Thursday, it's 1 o'clock. We're going to get our math on. Yeah. Hope everyone washed their hands. I don't want to catch anything from any of you. Okay. Just a little COVID joke. All right. Anyways, I'm going to take over the screen here. Bear with me. All right. So hopefully you can see right now in the top right corner here is the link to this presentation. I will be linking this one at the end. I'll show you the link again, as well as every other presentation we've done this week. Okay. But I think to get started too, I have to thank this brilliant guy working in the background, doing my marionette puppetry. Okay. Everything that's going on in the background is thanks to Chris. So I just want to give a shout out to him and his team at ATA, and thanks for all that work for them. All right, without further ado, mathematics. So I'm going to pretend that we're working on imagine this. You are a fierce knight or a princess, and you got your armor, and you encounter this three-headed, three-tailed dragon. A three-headed, three-tailed dragon. Now, what we're going to do is our job is to destroy the dragon. How to do that is you have to remove all the heads and all the tails. So a headless dragon isn't dead. A tailless dragon isn't dead. But a headless, tailless dragon is. So hopefully that makes sense. Now what I'm going to do is actually take over this screen on my iPad here. So then I can we're going to actually do some work here. And I want you to, if you don't want to have already, get a piece of paper or a whiteboard or something you can write down on. And please do that now. And while this takes going, and now you should be able to see this, hopefully. So it's the same screen, just now on a little whiteboard. So imagine this. If you have your little piece of paper, we're going to draw a dragon. I'm going to draw a three-headed dragon. One head, two head, three head. And one tail, two tails, three tails. So a three-headed, three-tailed dragon. Now what I'm going to do is I've given you a couple choices. So if you've worked on this puzzle before, I've added a new sword. So some Red Deer Catholic people might have seen this because I used this before. But I'm going to work with the sword of hope. So that's kind of where I'm looking at right there. If you want, you can work with the sword of justice. And I'll kind of explain that after. But here are our options, ladies and gentlemen. We can cut off one head. So you see here, if you cut off one head grows back. Okay, well, let's do that. If I cut off this head, head gone. Oh no. What happens? Well, the head grows back. Okay, not that interesting. Not that interesting at all. So let's go back to the next one. I could cut off two heads. If I cut off two heads, nothing grows back. All right, let's do that. Sorry, that's my ferocious cheer, okay? If I was a knight, that would be the scream I would yell. Okay, now nothing grows back. Okay, so I have a one-headed, three-tailed dragon. Interesting. I'm gonna go back. Let's pretend I decide to cut off one tail. If I cut off one tail, what ends up happening? 2 tails grow back. So now I have a 3-headed, 4-tailed dragon. Interesting, interesting, interesting. The last thing you could do is cut off 2 tails. And if you cut off 2 tails, 1 head grows back. 2 tails gone. No! And what happens? Look at this. Now I got a 4-headed, 1-tailed dragon. Oh no. Okay, so here's the task. Using these kind of opportunities, so either cutting off 1 head, then 2 heads, then 1 tail, then 2 tails, in a whole bunch of different orders, how can we slay the dragon? And you can see some questions down there that as you're playing with this, I kind of want you to explore. Is there a dragon you can't slay with the Sword of Hope? Is there a certain dragon? And if you think Sword of Hope is awesome, try the Sword of Justice, where different things happens with different slices. So I'm going to give you about 3 minutes and 28 seconds to try to slay the 3-headed, 3-tailed dragon with the Sword of Hope or the Sword of Justice. Good luck, knights and princesses. May the force of Pythagorean be with you. I will watch the chat. If you have any questions, let me know if there's any. Okay. You bet, Alan. We are going to rock and roll in the math world. So hopefully you're playing around with that. No, Robin, you can't use both swords. So for this task, you either choose the Sword of Hope or you choose the Sword of Justice. However, saying that, you just blew my mind. That is a brilliant, brilliant enrichment question. What if in your backpack you had the Sword of Hope and the Sword of Justice? What then? What is the minimum number? So I think that already is a cool question, which, you know what, I know what I'm going to be doing tonight. I'm going to be talking about the Sword of Hope and Justice and seeing what ways we can kill these dragons. Great question. And if you got it, I want you to type in the chat what you think is the minimum number of slices, if you will, like things you're cutting, to make sure the dragon has no heads and no tails. I just got a private message, just so I'll answer it to everyone, is yes, the dragon may end up having more heads or more tails than it started with. You could end up with a 7-headed, 8-tailed dragon, maybe. Eight slices, Sword of Hope is what Chris states. The gauntlet has been thrown. Can you do it in less than 8? Or can you do it with the Sword of Justice?
Only math teachers would find this exciting and a fun way to start a workshop. Eh? Like, whoa, this is awesome.
Who doesn't like fighting dragons? So I see a couple people just have joined. I'm just going to highlight something on the chart. We're fighting a 3-headed, 3-tailed dragon in this lovely picture, and we're doing the Sword of Hope. You can choose to cut off a head, and if you do, 1 head grows back. You can choose to cut off 2 heads, which nothing grows back, just the dragon loses 2 heads. 1 tail, but then 2 tails grow back. 2 tails and 1 head grows back. 112, I will give you 1 minute and 34 seconds, and we will continue on. Hopefully you're engaging in this. Sword of Justice? Yeah. Jillian, how did you do the Sword of Justice? How many in Sword of Justice?
I cut off all the tails first, which gave you 12 heads, and then I just 2 heads every time. Nothing goes back. So you hit the head 6 times, 12 heads are gone.
Nice. So take out the tails. How did you take out the tails though?
Says one tail, nothing.
Oh, I get it. You did 2
3
tails.
heads grow back, so you end up with 12 heads, but then you go 2 heads at a time. Nothing grows back, so you hit the head 6 times, all the heads are gone.
I get it. Cool, cool. Awesome. Gonna give everyone 29 more seconds. If you haven't figured it out, that's okay. It's awesome. It's an awesome problem to play with. And I'm going to show you something even cooler, if that's possible. Also, if you like what I'm using here, I will be talking about that after. Okay, so for those who are kind of still working on that, what I love about this though, ladies and gentlemen, what I absolutely love, this question, believe it or not, has some really, really cool graphical implications. Because think about this. What if I just actually made an X and Y grid? And I called this down here maybe heads, and this tails. So what would be, if I wanted to graph a dragon that has 3 heads and 3 tails, what would be the coordinate I would actually graph? If I wanted 3 heads, 3 tails, what would be the actual coordinate or the point that I would graph? Anyone want to throw in chat? What do you think the coordinate would be? A 3-headed, 3-tailed dragon? Awesome, Chris. Yeah, 3, 3. So obviously it'd be 3 heads and 3 tails. And so this dragon would be kind of here. And then believe it or not, you can actually use each of these little things to talk about a horizontal or vertical movement, right? That one won't be interesting. I think we all agree cutting 1 head and 1 head growing back is literally doing nothing. But 2 heads and nothing grows back. Well, if I cut off 2 heads and nothing grows back, it would be the equivalent of essentially just moving that point vertically down too. Because now we would have oh no, I lied. I'm going to cut off 2 heads and nothing grows back. My apologies. That was just a tricky one. We're actually going left. My bad. To 1 head and 3 tails. Hopefully that makes sense. If you cut off 1 tail and 1 tail and 2 tails grow back, it's actually a movement of a vertically up one now. And so what I'm going to do now is take back over the screen with my presentation. Is what you can get here now is this. So I've seen this picture on, we shared this out actually, and what you got is, this is what someone did, and they actually related it to graph theory. And so you actually can see here is what it is. It's just, now high-end we call this vector, right, vector theory, but this is an interesting way that you can talk about coordinate systems. And so when we say which dragons can't be done, what we're really asking is what point, if you only have these kind of translations available, which points can you not bring to 0, 0? Of course, you can also talk about what would be the domain and range of these graphs. Could you have negative heads? Could you have negative tails? Is this discrete information? Is it continuous? Can you have 2.5 heads? And so those are kind of some cool questions that can come out of this. Just a really, really awesome task that has some rich mathematics kind of embedded inside it. Really, really cool. So hopefully that makes sense. That's a cool way that you can kind of integrate. I think in a lot of high school classes, you can integrate coordinate geometry into this. Math 30-1, you can talk about transformations. Yeah, so hopefully that all makes sense. Okay, next thing is we have to celebrate, ladies and gentlemen. The diplomas are not this year. Isn't that amazing? And you know what's even cooler? Teachers are still working and students are still learning. Oh my gosh, hey? Anyways, just had to celebrate, awesome. So what we are, and this is what my session is going to be about today, is now knowing that not everything's going to have one little question on it, like, you know, those all the relevant outcomes, but you're going to see one question on the diploma, so we got to cover it. We can kind of, as Elsa would say, let it go, let it go. Anyways, okay. Anyway, so if I had to come up with the essential outcomes from grade 10 to 12, so what I did is I kind of went through the math curriculum, high school math curriculum, and if I pulled out ideas, like really big ideas, these would be the ideas I would say are important. Now you have to be careful. These are not found in every single course, so I'm going to rely on it and make sure if these do show up in your curriculum, I would say you should make sure at least, if you haven't stressed it already in a classroom, that these are the things you should still be at least covering on the online world. So proportional reasoning, we all know this. Students need to understand in the real authentic world how proportionate reasoning works. Miles to the gallon, different tax rates. Those things are obviously prominent in our everyday life. The next thing is, I would say, students should be familiar with the parameters in all the different kind of functions, whether that's linear, quadratic, sinusoidal. So do they understand what A, M, X, B, and all those things do? Of course, those do not show up in all grades, but if it does, I would say that's an important idea. Understanding of trigonometric tools. Next is the distributive property. I do not like the word FOIL. FOIL is a 4-letter F word in my mind, and you should not be saying it in class. Why? Because FOIL works on 2 terms by 2 terms. What we should be saying is the distributive property. Distributive property actually applies to radicals, polynomials, fractions, and any kind of terms multiplied to any amount of other terms. FOIL is really kind of a cheat sheet for a very specific kind of expansion. So I would caution you on that. Okay. Explain trig tools. Sorry, trigonometric. I meant equations there. My apologies. Thanks, Isabel. The word tool should not be there. It should be the word functions. My apologies. Okay. Understanding of factoring. The reason I say this again, factoring comes in many different ways, but we usually have a factoring unit where we deal with polynomials only. And then we talk about reducing radicals. I would propose that we just talk about it called factoring, right? When you rewrite say a whole radical as a mixed radical, we're really just kind of doing some form of factoring. We're taking something out and putting it in front of another form. So I don't know if you've ever thought of it like that, but we should more kids should understand kind of what factoring is. What is a function? That is a huge question. And I don't know about you, but in my classes, that was one of the hardest things to understand. But do students really get what a function is when we're dealing in high school? That there's an input and kind of an output out, and those things change. Solving equations multiple ways. I know, we do heavy on algebraically, but I would encourage you now in this online world, are we going to arm students with tools that they can do it digitally? And I'm going to show you some examples about that. Obviously in 20-2 only, I really wish statistics was everywhere in every grade 10 class or every high school math class. I don't know why only in -2, but statistics is huge, right? We would want kids leaving those courses knowing what average, what standard deviation means. And so when they read, say, reports in the news, are they understanding what that means? 30-2 people. I don't know who my 30-2 peeps are, but rational expressions, I would not be worrying so much about that. I would not be worrying if my 30-2 kids can factor and add rational equations and do all that. I would be more stressing the permutations and combinations. You'll notice I say that only for 30-2. And why not 30-1? Because the -1 kids are going to need those other tools, those algebraic things as they go into post-secondary. Those kids are more likely to use the math that they're going to build in high school. Let's be honest, our -2 kids, no insult to them at all, by no means. They're going to just be working with mathematics differently. They're going to be working with the applied and the application of things. And so we want to make sure that we are arming those with the right things. And most importantly, less is more right now. I think we can all agree with that. While I've heard of teachers maybe taking booklets and printing them off and sending them home and normally what they would do in the classroom, I would say use that as a Band-Aid solution. And let's start kind of removing the Band-Aids and start saying, well, how can we ask maybe 3 really, really important questions as opposed to 30 redundant, changing the numbers where it's very algorithmic thinking. Okay, so hopefully that made sense. I just wanted to kind of go through. Those are the things that if any of these big bullets appear in your course and you haven't done that, I would make sure that is brought in. And thanks, Jen. Awesome. I'll have to check out that YouTube clip for what is a function. Great. Okay, so moving on in is, if I had to sum up everything, I would say this. Essentially what's important in high school is that students understand different forms or equivalent ways of expressing things. That there's different ways to write a radical. There's different ways to write a polynomial. There's different ways to write a sine function. There's different ways to write a quadratic. And the second thing, which is just as important, ladies and gentlemen, just as important, are they enjoying mathematics? Because I really think math is so beautiful and so awesome. And the last thing we could be doing or should be doing, not saying you are, but I want to make sure we don't, is teaching kids how to hate math digitally. That's the worst thing we could be doing, okay? So let's now talk about how do we bring joy, how do we bring awesomeness to math? And I think we will start actually playing a game, okay? So I don't know if you've ever played Polygraph, but I just want you to watch my screen, and then I'm going to show you how to play it, and we are all going to play against each other in this kind of awesome game. So Desmos calls it Polygraph. It's actually called, it's kind of similar to like Guess Who. I don't know if you've ever played the game Guess Who. Hopefully you have, with the little faces. And so that's what we would do there. So what I'm going to do is I'm just going to show and go to my other screen. And this is what we're going to play. You're going to get, I made a polygraph for us. Now, I understand everyone's at different levels. So if you don't know what these functions are, I'm going to ask you to use your creative mind. And you can see that there's a whole bunch of, well, not a whole bunch, 16 to be exact, of functions I made. Chris Gonzalez has picked one. We don't know which one he's picked. We are only allowed to ask yes or no questions. So in the chat box, I will take the first question. What is a question I could ask, a yes or no question, that is true about some of these and not true about the others? Excellent. Is your graph a function? Is it a function? Now, what Chris gets, we don't see his screen, but what Chris gets here right now is a little bullet that says yes, and a little bullet that says no, and a little bullet that says I don't know. And if he doesn't know what a function is, that's cool. As a teacher, I'm going to show you that we can see all these things. So Chris, answer is it a function? He says yes. Now what we get to do is we totally get to do guess who. So that's not a function. That's not a function. That's not a function. I think I got them all. Eliminate selected. Okay, next question. Is domain, is it linear? I'm just going to take them as I go. Is it linear? So Chris, is your function linear? Meaning, can we do it with a straight line? He said no. Get rid of those linear functions. I think I got them all. Done. Okay, next we'll say, is it trig? So is it sinusoidal? Is it sinusoidal? In case you don't teach those, that's these guys right here, these little kind of like waves. So no, they're all gone. Does your, someone asks, well, actually someone says, does your parabola have a negative a value? We'd want to be careful, Carrie, because you're assuming it is a parabola. So let's actually ask that first. Is it a parabola? Now, if you don't know what parabola is, I'll tell you right now, it's these little kind of half circles here, these U's. Brilliant. He said yes. Oh my gosh, Carrie, I am so sorry. I should have asked your question because he is a parabola. Now we go back and ask, is it a negative a? Negative a. So negative a is really what we're asking is, does it open downward? Does it open downward? So this would be a negative a value. If he said, I was hoping he said yes. Okay, what could we ask that differentiates this from that? Is the y-intercept 0? Y-intercept 0? Is the y-intercept 0? Yes, but the problem is they both have y-intercepts of 0. Okay, so that doesn't, okay. Does your function have 2 roots? Awesome, 2 roots. You know what? This is brilliant. Whoever asked that, Logan, the reason I asked this, and it's really cool, this is a cool question to ask in class. Does this parabola have 2 roots? See, I think he's saying, but some of us would say, yes, there is 2 roots. It's 2 equal. At the end of the day, it doesn't matter, but I'm just saying something really kind of interesting to talk about. All right, I did it in 7 questions. Does that make sense how this is kind of working? What I'm going to get you to do, and then you have this question here. At the end of the game, you would ask, how would you differentiate these 2? And that's just for the teacher side to get things. So what I want you to do right now is open up a browser. Please open up a browser. If you don't have one, you can go on your iPad. You can even do it on your phone. It does not matter. Any kind of device at all will work. And I need you to do that. So go to student.desmos.com. Chris, too, can you just, if you want to close yours, or else you're going to get paired with someone. So what will end up happening, and I'm going to go through this with you right now. So if you click in student.desmos.com and then type in this value. Chris, can you type that in? I'm going to share that link in the chat there. Actually, I got it too. Okay. So there's the code and there's the link. Student.desmos.com. And the code is Y2V B5K. I don't know, military. Oh, which one? You mean this link here, Steph? Okay. All right. What I can see now are people logging in. What I'm going to show you is I've anonymized it. I'm going to talk about all these kind of things later, but I just wanted you to see what I can do. So what I want you to do is play a game. You will automatically be paired up with someone. This is so cool. As soon as you're ready to go, you're paired up with someone. Okay? And play. We're going to give you, I'm going to get you to play 1 game. So play 1 game. I know some people are going to be the guesser. Some people are going to be the picker, but then, oh, I didn't know. I see. Steph. Yeah, touche. I could have done that a whole lot easier. Sorry, Steph. Okay. Just go, Jillian, if you just go to this link there, or Or if you already have student.desmos.com up, that's the code you would use, the Y2V. Here, I'll just pop that up on my screen here.
It's at the back of your link as well. It's the last 6 digits in the link that if they already have it set up.
So I see people playing. Hopefully you're having fun. So cool, so cool. Give you guys about 2 more minutes. Yes, absolutely, Steph. Yeah, if I was going to give it digitally, you're right. I would throw that one in Google Class. Oh, I see someone got it wrong here. Just give me someone just say done or give me a thumbs up, just so I know when people are kind of finished their first game. And when I see a lot of people done, I'll wait maybe 34 more seconds after that, and then I'll continue on.
If you want, Dave, they can click the yes check mark under the participants, and that will just give a quick list of all of us.
Oh, sweet. Okay, so if you're not, I'm going to give you about 60 more seconds. I know if you're not done, I just wanted you more to experience this. I see a lot of people have used this before. Yes? No? Okay, no. It's cool though, hey, Lynn? Okay, if you're not done, I'll ask you to close down now. But stop. So if you're halfway through a game and the person leaves, that's my bad. That's not their bad. Okay, that's my bad. But here's what's cool. You can actually have this link going. So as we're in world of asynchronous, if you have it going and someone logs in, they automatically get planned. And so what you could do is say maybe an hour time slot. I'll open the link from 1 to 2, and then anyone that comes in goes. You could play with kids, obviously. You could do a one-on-one. You could have it open up for all day, and as people go in. Okay, so I just wanted to show now what I see from my end. What I see from my end here, and I just got to remove these chats. Okay, is this. So I can see people. What are your questions? I can see exactly who you are. I've left it as an anonymized, and I don't want to. But in a real authentic classroom, you might actually have kids, I would say, using their authentic name, and then you can actually kind of keep track of this. Please, please, please do never show out this list if it's not anonymized. Why? You don't want to be embarrassing the one kid that got it wrong, okay? And let's be honest, right now in high school math, we have a lot of kids who are already logging on, convinced they're not going to be able to handle what it is that you're going to teach them. And so the worst thing we can do is feed that fire, okay? So the other thing is, and so I just wanted to show some things, is so if you go to this, teacherdesmos.com, okay? There's also one, so I'm just going to go to this. If you go to teachers.desmos.com, I'm sorry, is you could do Polygraph. Polygraph's awesome, but there are so many other things, like way, way cool things. You simply search for an activity up here. You can see Polygraph linear. I wanted to show you some other things that I've seen, like this one. This is called turtle crossing. And so if you just simply search turtle crossing, you'll see it. This does something that, I don't know if you're familiar with what the SAMR model means of technology, but SAMR is substitution for S, but R is redefinition. I want to show you why Desmos can redefine, because right here, I am able to do something that I cannot do without technology. So check this out. I'm actually just going to draw a distance time graph, some random things. And look what Desmos does for me. As soon as just got to do this. As soon as I push play, the turtle follows my graph. So without even knowing anything, just by graphing something, you can actually have kids kind of play around with this idea. And sorry, right there, check that out. I don't know if you saw that. You could even talk about that. Why the heck are there 3 turtles right here? Ready? Watch this. 3 turtles up here. Okay, I think you probably all know why. but just in case, like, look at this, 3 turtles, all appeared, right? What a beautiful way to explore how if you don't make it a function, crazy stuff happens, okay? As opposed to talking about why a distance time graph should always be a function, okay? So there's a couple things, just you can even have more fun if you have more than one line going, all of a sudden more than one turtle appears, so that's fun. Like, I don't know, this is just days and days of joy right here. So that's a cool activity. But I really want to talk about is that there's so much stuff you can have in here, all created by other people, Marcellus the Giant, some lines, and so on. Okay, if you actually have a favorite Desmos activity, marble slide, yes, I was going to say just write it in there. I've seen people do this already. Yeah, marble slide is great, where you actually have to draw the line and the marble goes. It's great. It's beautiful. Okay, but just go to teacher.desmos.com. If you just sign up, you could sign in through Google if you have a Google account, and then it saves it all stuff in there. Just in case you haven't, just in case you don't know, where you want to save things, if you click plus, is how you save things to kind of your collection. That would be, in a sense, how a Google Drive works, just like on Desmos, okay? Just going to touch on these things. I see a lot of people have used Desmos a lot, so thank you for bearing with me, okay? Oh, Dave, Steph, can you share your links to those collections? That'd be great. Yes, Chris.
I believe it is yes, but Desmos is primarily graphing. Is that correct?
Correct. GeoGebra is another one for geometry. So if I'm not going to include GeoGebra today, but GeoGebra is exactly like Desmos, but GeoGebra is more in a geometrical sense. If you want to play with circles, tangents, and so on, you would go to GeoGebra. Okay.
Perfect.
I want to talk about the power of these tools here, because what you're seeing right now is obviously Super Mario Brothers, which, by the way, is the best game on the planet. Okay. So I'm just going to start that right now. I know you can't see my physique, but I have a very big belly because I love Super Mario Brothers. All right. But what you're looking at is an ability of now what we can take relevant, authentic mathematics, and just through the power of these online tools, we can actually do something like this. And maybe ask the question, where is the best place you should jump off Yoshi so you have actually land above the block? That's a calculus question. But what you could also ask is this. Imagine we threw this in a class and said, is that parabolic? I mean, we see chains all over the place. Is a chain that droops parabolic? Yeah, match my parabola. Worked pretty good with Desmos. I love it. The answer, though, by the way, it is not parabolic, ladies and gentlemen. It's actually what we call a catenary, or a hyperbolic cos function. I remember when I taught, I see people popping these out, grade 10, grade 11. We talked about hyperbolic cos functions, not as a way they need to learn it, but if you click on this picture, boop, it takes you to this beautiful singing banana. But after that is done, okay, after you get what's called the catenary. So after that ad is done. And the catenary is a really cool function. But nonetheless, this is an ability where maybe you show a bunch of pictures to kids and say, which one's parabolic, which one's not? Is it linear? Is it not? And you have the most beautiful, beautiful set of data, COVID-19 cases, and Math 30-1 kids. Is this exponential growth? Are we flattening the curve yet? How would we know? What is a logarithmic function? What does that even tell us? And I'm being sincere when I say this, and I don't know if you've seen this site, but if you just search Corona Worldometer, and actually I'm going to throw the link in right here so you don't have to do this again, but if you check this out, even when I scroll down, look at this. It has a logarithmic scale to it. Why the heck would it show data in a logarithmic scale? What a brilliant question to ask in a Math 30-1 classroom. And so these are just some, again, some really easy tools that we can take this data, throw it in graphing software, and let the graphing software do the work for us. Of course, you can do this all in a TI-83 too. I just think now that kids are at home, why use a system that costs $180 when we can use an item that costs nothing? Okay, just my 2 cents. Okay, so one day maybe you do a Desmos activity. The next day, try some open middle problems. Open middle, if you haven't seen, is kind of like a Sudoku style pose question. And you're seeing one right here that I think would work great in the grade or high school classroom. Is you're allowed to put the numbers 1 to 20 anywhere in here. You cannot repeat any of the numbers, but you have to make sure the whole thing actually is equal and equivalent. And so what a beautiful way to actually then start asking, how many answers are there? Or my favorite is to ask teachers or kids, what's the coolest answer? And the reason I say this, coolest, what it is to me and what it is to you are 2 different cool things. But I can tell a lot about if a child's, knowledge, if I see what he thinks is a really interesting problem, okay? And of course, the last one is, the last thing we should be doing with these things is what if we had students create them? So on a Tuesday, maybe you have, okay, boys and girls, let's try this open middle problem. Submit your answers. Wednesday, what I want you to do is submit an open middle problem. And then Thursday, I'm actually going to share everyone's open middle problem with everyone else in the class. And kind of like a Guess Who project, they get a critique. And then that could be your formative assessment. Okay? So hopefully that's making sense. Is that open middle? Sorry, I should just click there and go through it. I'm just looking at the time. We got lots of time, or not enough, a lot of time. If you click on high school, open here, there's a whole bunch of open middle problems. Okay? Awesome, 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 awesome. Okay. Next one is menu math. I don't know if you've heard of menu math. Menu math is such a really cool thing. So I made this menu math with numbers, and this is honestly where I would start. No matter what, I would probably start with a menu math. So I'm going to do this. Okay? Menu math is you are trying to find a list of numbers. A list of numbers. And I want the list as short as possible, such that somewhere on that list, there's a positive number. Somewhere on the list, there's a number that can't be written as a fraction. Somewhere on that list, the sum of the digits of the number is 12. The product is -1 or -48. One of the numbers is more than 30 units away. Oh, and the other one is between -1 and 1. Sorry. So what I would say is what I love about these tasks is this. Yes, you have unlimited access to Desmos, absolutely. So here's an activity where we would maybe pose this with students where, okay, so they could say a number that's positive is 4. Let's go pi is the next one. The sum of the digits is 12, maybe 84. But now what I'm doing is I'm just coming up with a number for each one. The more complex question is, can I come up with a number that covers more than one? So that's what I want you to do right now. Can you write in the chat box a number, one number that you think covers, checks off a lot of the 6 out of these things? I don't know you can check off all 6, but can you check off a lot of them? So can you come up with a number that would check off maybe positive, would check off maybe can't be written as a fraction, sum of the digits is 12, the product is -48, more than 30 units from 0, and is found between -1 and 1. I'll wait for someone in the chat to write something. Ooh, nice. Awesome, Carrie. Thank you. So 66 covers A. Awesome, it's positive. It covers C. The digit 6 plus 6 is 12. And it covers E. It's more than 30 units from 0. Excellent. And so just like that now, 0.14, is that what it is? Excellent. What you can see now, though, is what we want to do is, 0.314. Awesome. What you can do is, with this activity is, I would do the first one is this, because we don't want the math to be the barrier. The kind of activity is going to be the barrier. But then after that, oops, sorry, is you can do it with rectangles. So this is where, and I've been saying this kind of all week, those essential ideas, you'll notice, I've missed out a lot of outcomes. But we still have to cover them. I want kids to know what a perimeter is. So why don't we do it through the lens of an essential outcome? And so now you're seeing is a menu math about perimeter and rectangles, but the bigger idea is, can kids multiply and add and subtract and do all those things? So can they draw a rectangle that where one of them, so they're drawing a bunch of rectangles. Obviously you could do it in 6 rectangles, but could you do it in less? Such that the perimeter one is greater than 20, the area is there, the rectangle can be separated into 2 identical squares, the perimeter is odd, the area is larger than the perimeter, and the lengths and widths are equal. And so these are kind of some cool tasks that you can do. I've shared some more in here, fractions. So kids, can kids build as few fractions as possible that has this, okay? I'm gonna clip through these a little faster, just you can go on your own time. Here's one that's quadratic. I ran this in an authentic classroom, worked awesome, it was beautiful, okay? So can students, you could use this now. Ooh, look at this, some symmetry between quadratics and Desmos. Kids could draw the functions in Desmos and submit them as a menu math. Oh my God, goosebumps, I'm just thinking about that. Okay, that's awesome, that's awesome. Okay, order of operations, you can do an order of operations one. So they have to, don't click on the order of operations one because that link is broken right now. And if you click on more and more and more, you bet, Paige. I'll get Chris to do that. Is if you go here, here's now a list. These actually, this idea was created by a gentleman, Nat Banting, out of Saskatchewan. And they're in French, there's in English, and here you go. They're all kind of here. These are all over the place, not necessarily high school. The ones I've created are more high school-y. So there you go. I will fix that order of operations link as soon as I'm done this conversation, this webcam. So just don't click on it now. It will work in 19 minutes. Okay. Next is, after you do a bunch of these, the bigger question now is, can you get students to create them? Can you get students to create a menu math that can be done in exactly 2, exactly 3, exactly 4, and so on? Okay. Steph, you made one of these? Sweet, sweet. That's awesome. That's awesome. Okay. The next one is this. Make sure that in your weekly plan, and I know it's high school, I know we got to do content, but we got to make sure we also have some space for joy. So as you noticed, I said earlier, is make sure that don't forget joy is, and we want that there. Here's a whole bunch of different puzzles I love that I work on myself that I think high school kids would also like. And they also have a good way. There's some really deep mathematics in every single one of them. Okay, even like Zuki, I was showing some people this yesterday, but Zuki is, can students do some abstract thinking or some spatial awareness in a puzzle form? Meaning, so grade 10. Oh, I see Steph. Yeah. Steph, awesome. So here they have to connect dots, only the dots given, and they have to do it to make a square. Well, that one's kind of easy. You can connect these 4 dots here if you look at my cursor. Rectangle, you have to connect 4 dots to make a rectangle. Oh, right here, that's awesome. But they get a little trickier. An isosceles, a parallelogram, a trapezoid, a rhombus, okay? So these are a really cool site, and this is a really cool puzzle, but really talks about kind of those 3D shapes, or 2D shapes, sorry. There's Math Adventures, Brain Bashers, Think Fun, which are kind of strategy games, okay? And then over here is one of my coolest links ever. I love this link. I look at this all the time when I get bored. These are 12 $1 million math pickle problems, right? Put your kids in a pickle. What these are is, now they start at grade 1, but obviously some of your kids might be really engaged in these. These are problems that have not been solved, but have been brought down to a level that kids can actually kind of work at. The Collatz problem is amazing. The Collatz problem is this, and it's a conjecture that if you pick any number at all, if it's even, divide by 2. If it's odd, sorry, I'll kind of scroll in here just in case you can't see that. If it's even, divide by 2, and if it's odd, multiply by 3 and add 1. You continue doing this forever, you will always end up at 1. The problem is no one's ever proven that. Computers have actually checked a whole bunch of numbers, but no one has ever proven that this works for all numbers. And if you do, ladies and gentlemen, there's $1 million on the line, and Chris and I want 10% cut because we're the ones who brought it to you, okay? That was in the formality when the fine print at the beginning, okay? Is this making sense to everyone? We're going good? Yep. Okay, continuing on. Other essential tools. If you haven't already, I would say as soon as you're done this, get the Google add-on Equatio. There is a bunch of ATA websites that workshops have gone about how Equatio works, but I would say it's what you can do is how you can type in this kind of, the math stuff inside. You know you have Equatio when you have this lovely blue thing right here. This rhombus, a square, a diamond, okay? I would definitely make sure you have Equatio. It's absolutely free for kids, and it's absolutely free for teachers right now. Free for teachers always, free for kids during this time, okay? So I would try that. The next thing is, high school math people, share out these, share out these YouTube channels. Numberphile, Vsauce, Veritasium. These are amazing, engaging people that showcase some really interesting problems. Numberphile is, and I'm telling you right now, ladies and gentlemen, get your favorite drink, load up Numberphile, and there's your Friday night. You're gonna be sleeping with a big grin on your face after you learn the amazing stuff they have to offer. Okay. Next is, if you have an iPad or a tablet, I would get the word Show Me, or the app Show Me. The app Show Me is what I used for you, what you saw when we were doing the dragon problem. It's a free app. I personally use it. Explain everything. I've played with it. I've seen it used, but the problem is I find to get the most out of it, you have to pay the extra $5. I'm a teacher and cheap, so I went with the Show Me version, which is free, okay? Next is mobile math. All right, people, all those kids who are like, I can't do algebra. Click on mobile math. And this is, you've seen them before. You've seen Mashup Math probably, but these are brilliant activities that really play with the idea of algebra. So for example, right here, we know it says this is 12. This is balanced, so both sides have to be 6. This is 5. I can already do some math now and probably figure out what the other two are. what's beautiful about this, and I'm going to put the wrong numbers in, it tells me that, oh my gosh, I've made the left side more heavy than the right side. It gives kind of a formal or in a formative assessment feedback in a visual form. It's beautiful, beautiful. I don't know if you've ever seen mobile math, but it's an amazing site. I definitely would go there for the kids who struggle with algebra because it's more of a game. Okay, Desmo's Polygraph, I showed you that already. I definitely would check those out. As well as this, there's a whole bunch of programs and apps and sites and links all in there. So this is Red Deer Catholics, our site. Feel free to take anything off this, use it however you want. You have absolute permission. And here are some actually activities like cows, bovine math cows. Great. I got to show this one because this to me is like one of the coolest, I would say, kind of little ideas. It's kind of a Sudoku puzzle where it talks about cows adjoining fields. So the number of cows in each field adds, the sum is on the bridge. And as you can see, as they get harder, some more things happen. And right here is my favorite. One of these can't be solved. Which one? I love doing this, and this is what I wish textbooks did more of, that we gave kids problems that might not have a solution, but ask them, how do you know they don't have a solution? So for 10C, when those systems of equations are coming out, here's a beautiful site that you can actually talk about. Of course, this doesn't have to be integrated just in 10C. This could be integrated in 20-1, 20-2, and some more algebraic thinking. Okay, so hopefully that makes sense. I'm not going too fast here. All right. And then this is all the stuff, and I've been, no one else got this, ladies and gentlemen, only you guys, because I taught as a high school. I'm a high school teacher by trade. Here are a whole bunch of things that I have used in my math classes. So I'm going to be honest, it's a little heavy with calculus, Angry Birds there, assessment of derivatives, like photo reduction. Okay, for those who are doing geometric series, you'll see what I did in a school. I took a little picture. I literally videotaped myself changing the enlargements, and then the question was, what was the final image? So again, a video all set up here for you. Every one of these links takes you to an authentic lesson plan with everything kind of set out for you. I don't want to go through all of these at once, but permutations, combinations, here are 5 lessons, 5 digital lessons. So my math 30-1, 30-2 teachers start with a little funny joke about a guy watching people's pin. Then it goes into this, and then there's a whole bunch of questions the students can kind of go through. So feel free to use any of this stuff at all on your own. You do not have to ask me permission. It is now yours to change and manipulate however you want. Okay, the next thing is this. I know that if I had to graph probably engagement of high school students, it would have started really high. They're like, oh my God, look at the novelty, we're online, right? And then it's, okay, every teacher I've talked to has said that as the days go on, it's harder and harder to get kids. And I get that. We don't have the, say, the carrots that we can use in a classroom, like personal relationships, pacing, wait time. We don't have that anymore. So I'm going to challenge you to allow the beauty and wonder of mathematics. And I really believe math, the beauty speaks for itself, okay? Just show this to kids. If you have kids who are struggling with multiplication, prime factorization, looking at numbers differently, just show this on a link and saying, what is this? You'll notice it's perfect squares, but why are the numbers colored the way they are? This was made by a gentleman by the name of Dan Finkel. Amazing guy, mathforlove.com. He has a brilliant board game called Prime Climb. But again, I think just this right here, it adds some mystery. It adds something different than as opposed to what's the prime factorization of 28? Okay, not that actually that isn't engaging at all. Okay, what's more engaging is what would be a number with lots of colors. And this is what you're seeing, is this is the prime factorization of every single number from 1 to 100. Super cool, super cool. This question, you see 3 cupcakes and 5 people. What? And then you ask this, how would you share 3 cupcakes with 5 people? How would you share 3 cupcakes with 5 people? Well, one obvious way is to just take each cupcake and cut it into fifths. But the problem is now, that's a lot of cutting. What if you just ask this? How would you share it with less cuts? Can you share these cupcakes so everyone still ends up with the same amount of cupcake, but you're not cutting every single one into fifths? Interesting problem. You obviously can easily differentiate this for different numbers of cupcakes, but it's a really, really interesting problem that plays around with fractions at a very deep meaning, okay? Pythagorean theorem, how joy is that, hey? Let's be honest. In a classroom, you leverage all those other things when you get a worksheet. with a whole bunch of triangles all over the place. Well, I want to show you Eridane's thread. I don't know if you've heard of it. Eridane's thread is, it's kind of this idea, and I'm going to take it over with my sheet or my iPad here in 1 second. But what it is you're looking at it right now. It takes on the story of the Perseus and the Minotaur. Okay, so there's a Minotaur, you probably have heard the story, where they're in a maze and he walks through with a thread. Why? Because when he's done, he wants to make sure he can get back. Okay, so I'm just going to load up my show me. All right, here's the task. How would I get from the start, so right here, and I have to get the Minotaur, which is way down here. Oh, I'll use a different color, sorry, so you can see it. And here's the task. Every time I move with a thread, the next move has to be longer than the first one. So what the heck does that mean? Well, that means is this. So say the first move I go is that. I think we'd agree that's a unit 1. That's 1 unit. Maybe my second move is here. Oh, sorry. Maybe my second move is there. And right away we have, how long is that unit? How do I know it's longer than 1? Well, I do know that has a length of 1, and I do know that has a length of 1. So using Pythagoras' theorem, 1 squared plus 1 squared, this should give me a length of root 2. Okay, I know that's greater than 1. All right, maybe my next move is this much. That's easy, I can count. That's a unit of 2, and I know 2 is bigger than root 2. And then maybe my last move is here, and you can see, using Pythagorean theorem again, that would be a length of 1. That's a length of 2. 2 squared is 4, plus 1 squared is 5. Oh, that's root 5. Interesting. So I got to the Minotaur in 1, 2, 3, 4 moves. Can you do it better? Can you do it with 5 moves? Can you do it with 6 moves? I don't know. These are the questions I would ask the kids. And so what I can share with you is there's another possible movement where everyone is getting longer and we have more moves than the one I showed you. And I'm sharing this with you. I would not share this with kids. I would challenge them. But here is the best move possible. That is the most amount of moves such that every move has a longer length than the previous one. And I forgot one other thing. The thread cannot pass each other. Obviously, if you come here and then you come back up to this spot right there, I don't know if you can hear, I'll move my here. The problem is now you're going to have rope around this twice. And that's going to be bloody confusing when you come back, right? You're going to die in the maze and no one wants that. So this is a beautiful, another example of a really engaging way to get Pythagorean theorem alive in a puzzle form, okay? How about this? This is just so wonderful. 30-2 people, all those and 30-1, you're doing permutations, combinations. Throw this picture at kids and ask them this. We are going to play a game. It's called Roll the Biggest Number, okay? I'm going to ask you. You are my students right now. We're going to play a game called Roll the Biggest Number. You get to pick any die you want. You can have the green die, you can have the blue die, you can have the red die. Which die would you choose if the game is called Roll the Largest Number? So you're going to pick a die. I pick a die from the other two. We both roll, and whoever has the largest number wins. Which die? Yeah, only one roll, Jane. Only one roll. So which die would give you the best probability of rolling the highest number? Which die do you think will have the highest probability of rolling the highest number? Type it in. Green. Sam says green. What else does anyone else say? Can't be wrong. Well, you can be wrong, but take a chance. The only reason you can be wrong if you do not write red, blue, or green. That's the only way you can be wrong in this. Awesome. Red, green, blue, green. Oh, a lot of green, blue. Okay. Are you ready, ladies and gentlemen, for a mind mess? No matter which die you pick, I can pick one that beats you. If you pick the blue die, I pick the red, and red will roll higher than blue on average. Why? All right, just go with me here. I think we'd agree that if you roll a 2, 50% of the time, I win. If you roll a 2 on the blue die, I win. If you roll a 5, though, I have a 1 in 6 chance of beating you. So it's 50% plus 1/6. Huh. If you pick the green die, I pick the blue and win. And hopefully you can see that the blue should roll higher than green. And green should roll higher than red. This should make no sense. How can blue roll higher than green, green higher than red, and red higher than blue? What? This is called non-transitive dice. It messes with your heads, ladies and gentlemen. You all know a game that is non-transitive. Rock, paper, scissors. Exactly. Chris, stop taking my thunder in the chat box, okay? Yes, rock, paper, scissors is a non-transitive game. Here's another one. Could kids create more non-transitive dice? Are these the only non-transitive dice that are out there? Here's another engaging activity that when we talk about probability and permutations and combinations, we might want to leverage to get some kind of wonder, I guess. Here's another one, and I know it's 1:58. I'm going to apologize. I'm going to probably go 4 minutes over. I am so sorry. Feel free to log off, though, if you have to go at 2. I totally get it. But imagine this. And I lost my rubber band. I think one of my kids stole it before they left. But imagine I have this little rubber band on it, okay? And every second, I'm going to pull the one end, 10 centimeters. But there's an ant on it. And the ant is only walking at 5 centimeters per second. So I'm pulling one end at 10. The ant is walking 5. Will the ant ever get to the end? If you click on this is a great video of this problem. Also, I made a bit.ly. And because I'm not lying, when I saw the problem, I stopped everything that I was doing. And I'm like, I got to see. And it is. You'll take you to this. This is a beautiful, beautiful an applet I made. That as the ant, you can actually change it. I made all these things. So you can stretch the elastic band here. Then the ant walks this much. Feel free to change these numbers. In case you don't know how to work Google Sheets, if you go File and make a copy, you will now have access to anything you want to edit. And what this does is it shows you that actually, yes, the ant does make it. And at the beginning, the distance is getting further. But actually, over time, the ant will end up making it to the end, which hurts my head because I'm pulling the elastic band faster than the ant is walking. Interesting. So that is a really cool way to integrate proportional reasoning, percentages, speed, velocity, all into one problem that has some really interesting implications, okay? All right, I want to end with this now. It's 1:59. Good, I'm trying to end really early here, but it's not going to happen. I'm sorry. I do want to remind you all, especially in the high school world, we're not online teaching. We are not. Unless you're trained in online teaching, then you're probably doing it. But most of us are not. We're just trying to do our best in a very, very hard time. And so please, 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 I know you're doing